Okay, guys. Wanted to go over something I don't think I did a very good job of on the last bit of notes, and that is the just making sure you guys can do the counting with the the situations that look like the chromium sulfate. So here's the chromium sulfate. So first of all, when you're doing this, we're crisscrossing. So this 2 came from the sulfate and that 3 came from the chromium. But I have to use the parentheses because when you pull a polyatomic ion, something off of the back of your periodic table, we use the parentheses around that. Learned that last year. And so let's take a look at what the heck is going on here and make sure that we kind of understand. So there's 2 chromiums. So see this 2 over by the chromium, that gives us the 2 chromiums. So there's 2 chromiums because the 2 is just going to multiply into the chromium. That's not that big a deal. Okay, but the sulfur multiplies by this 3, and then the 4 oxygens also multiply by that 3. So you actually see multiple things that are getting multiplied by that 3. So what does that look like? You're going to get 2 chromiums, but then see 3 times 1. Remember, there's a little 1 there for sulfur. 3 times 1 gives you 3 sulfurs, and then 3 times 4. See 3 times the 4 oxygens right there, times these 3. That's going to give us 12 oxygens. So you get 2 chromiums, 3 sulfurs, 12 oxygens. And that is how you get that answer. Whoops. That's how you're going to get the answer for the 392 is by using those values. Okay, so like I said, this 392.21, that is based upon these values up here. So if you didn't get these in your math, then you would have got the answer wrong. All right. Okay. So let's go back to the notes and let's take a look at the next section, which is actually using the molar mass to go back and forth into moles, things like that. Okay, so first thing, go down there to B, Avogadro's constant, Avogadro's number, 6.02 times 10 to the 23rd per mole. Want to put a star by that? What that means is that when you want to create particles, ions, might want to write that down, ions, I-O-N-S, atoms, A-T-O-M-S, atoms, molecules, and formula units, which is 2 words, formula units. So ions, atoms, molecules, formula units, they all use the same thing. They are all going to use this right here. This 6.02 times 10 to the 23rd can give you ions, atoms, molecules, formula units. It particles, it covers multiple things. Okay, so if you look down here in the notes, I've got these diagrams, and these diagrams are showing you that over on the left, right over here, if you want to go from moles to grams, you're going to use molar mass, which is your periodic table number. So you might want to write above that, might want to write kind of over here on the left that molar mass, that's hey, go get your periodic table number, use that. Now, if you're going to do particles and go to moles, so anytime you're using ions, atoms, isotopes, stuff like that, we got to use that Avogadro's constant, Avogadro's number. So you might want to write 6.02 times 10 to the 23rd. That might help you out. So I'm going to show you some examples down here, and we're going to do some practice on that. So I'm going to switch back over and slide over a bit till I get to that one. Okay, so here we are. I'm going to go ahead and zoom in on that. All right. First thing is calculate, sorry, that's not the first thing. There's one above that. Calculate the molar mass of chlorine. That's pretty easy. So let's go to a periodic table and let's find chlorine. Hopefully you remember where a few of these are from last year. There's chlorine right there, 35.45. So let's go back over here to this and let's put that in there. So remember, we are all using the same periodic table, and we are doing that for a reason. So we're getting the same answers. If you're using your own, then you're going to get answers that are maybe not quite the same as ours. So I want you to use the one that I've provided. So 35.45 grams per mole. And then we're going to multiply that by 2, because if you look right here, we had 2 chlorines. So that 2 is because I had 2 of them. Okay, now this is a good time to talk real quick about significant figures. The 2 right here is not used for sig figs because it doesn't have a unit. So as a general statement, if you don't have a unit, that's not going to be used for significant figures. Okay, so we're going to multiply that, and we're going to come up with an answer. And I got 70.90. 70.90. 70.90. Now you need to go ahead and run that through your calculator. Don't take my word for it. As we've already seen, have gotten some of these questions wrong. I'm talking, I'm writing. I often miss those connections between the two. So don't trust me. I am not infallible. I have just done this a lot, but that doesn't mean I won't prattle on and make a mistake. Okay, so let's find this one. Pause this. Go ahead, find the molar mass of the acetylsalicylic acid on your own, and then unpause it and come back. All right, hopefully you have paused it. You're back. You're ready to see the answer. If not, you should stop, do this on your own. I will tell you guys, if you don't do the chemistry, you're not going to be able to do it. So don't just watch me write this down when I tell you to pause and try something. Pause and try something. So that's important. Okay, so carbon. Hopefully you looked on your periodic table and you saw that carbon is 12.01, and hopefully you saw that there's 9 of them, so I'd multiply by 9. Notice I use parentheses. Tons of students get problems wrong because they dump everything in their calculator and they don't take time to use the parentheses. You paid the $14 or whatever for your calculator. Use the parentheses that you bought. It's not hard. Just want to take your time. So the hydrogen weighs the 1.01, and then that's going to be 8 of those guys. And then last, the oxygen, 16.00. We're going to multiply that one by 4, and we're going to add all those up. Now, if you're sitting there and you were stuck and you couldn't figure this out, guys, go back and remember, this is where we're getting that information. There's the 16, there's the 12 for the carbon, and over here, there's the hydrogen. So this is not a mystery. We should know where to get this information. So just go dive into your periodic table. Okay, let's add these up. You add them all up. I got a 180.17, and then that's going to be grams per mole. Okay, grams per mole. So kind of ran out of space there. There we go. Okay, now let's actually do something with this information. So instead of just sitting here and not doing any problem solving, we're going to actually do some problem solving here. Very common. And I'm going to show you this and talk about conversion factors again. So the first thing we're going to do is anytime you have a problem like this, the first thing you do is you are going to write out the number and the unit. All right, the number and the unit. That you cannot start a problem if you do not do that. So always write out the number and the unit. So I'm going to start over here, and I'm going to go 0.509 moles. And you'll see that it's the same chemical, the acetylsalicylic acid. And so a good chemistry student would also write C9H8O4. Shortcuts are not a good idea in chemistry. They're going to get you into trouble, and they're going to get you into trouble really quick. So please take the time to write down everything that we are looking for. Okay, so let's do a quick conversation about conversion factors. So conversion factors are always going to be where you have the multiplication sign, and a line. That's a conversion factor. So to convert, what we're going to do is we're going to take the unit that we want. The unit that we want is going to be on top. So whatever I want goes up here, and whatever I have already is going to go on the bottom. So in this particular situation, what unit do I want? Well, it says in the prompt that we are looking for mass. Well, what's mass measured in? Well, mass is measured in grams. So I would put a gram on top. That's what I want. Okay, well, what do I have? This is what you have. You have moles. So whatever unit is there always goes to the bottom of your conversion factor every single time. So when you are doing problems in this class, if you're doing some kind of problem solving like this, just come over here, look at this unit and put that unit on the bottom. Do that every single time, and you are going to be more successful. Okay, so this is really, really important to do that. Okay, so now what numbers go in? Well, the numbers that go in are going to be based upon the periodic table. And so the mole is generally going to get a 1. Now that will change here in the future, but right now the mole is going to get a 1, so put a 1 there. And then the other value is going to, it says a gram, so then we're going to use a periodic table number. Well, we already found it. It's right here. We looked it up. Number 2, molar mass. Okay, well, that's grams per mole right there. And that's how much the acetylsalicylic acid weighs. So we're just going to drop that in right here. What's the periodic table value? So 180.17. So then we can take a look at what happens to our units. Well, they're going to cancel. Moles are on top right here. This is the top. And then this is the bottom. So see, the moles cancel. The only unit we have left is grams. And that is exactly what we were looking for. And so now we can do the problem and we can get our answer. So our answer, the way it works, if it's on top, you multiply, and so on bottom, you're going to divide. So we would take 0.509 times 180.17 divided by 1. So we multiply if it's on top, we divide if it's on bottom. So 0.509, you always start with that in your calculator, times the 180.17, enter, divided by 1, enter. Okay, so you run that through, and you would get the final answer. So let's go ahead and do that real quick. You should have a calculator. Don't just watch me do it. So 0.509, multiply. I'm doing this right now. 180.17. And then you get a number. And now we would have to decide on sig figs. So I got 91.70653. So from a sig fig standpoint, we don't get to keep everything. We're going to get to keep 3 because see, this has 3 sig figs, and we don't use sig figs with conversion factors. So that's a conversion factor. So I only care about the 3 sig figs over here. And so then I'm going to have 3 sig figs here. So we're going to actually round it right there. Going to go 91.7 moles of our C9H8O4. All right, so that's what we're looking for there. Okay, I'm going to run out of time on this particular part. I'm not going to get to part 4, so I'll go ahead and do part 4 next. But I'm going to pause the video. Once again, make sure you have the little things like this over here, the want